All right, guys, last FRQ number 5 of AP Physics 1 2024 actual exam. So let's read this one out. Looks like it's a question on collision. At time t equals 0, block A slides towards the surface along the block B, which is initially at rest. A and B mass is 6 and 6 and 2 kilogram respectively. It collides elastically at 1 second, and as a result, the magnitude of the kinetic energy of block B is 9 joules. All the friction forces are negligible. Remember the speed of B immediately after the collision. That's pretty straightforward, right? Because we are given that the change of kinetic energy of block B is 9, although they are tricking us by quoting the word change. But remember, initially the block is at rest. So initial energy is anyway zero, initial kinetic energy is anyway zero, and we are given that the change of kinetic energy is 9, which means that the final energy minus initial energy is 9. Final energy is just unknown, initial energy is 0, so it makes sense that the final energy is 9. And the energy is half mv square, and m is 2. V square is just v square is equal to 9. 2 and 2 is gone, so we are just left with v is equal to root of 9, which is 3 meter per second. So that is the speed of the block B immediately after the collision. The graph shows shown in figure 2 represents the position of x of block position x of block A and block B and the center of mass of the two block system as functions of time between 0 and 1 second, and the center of mass of so the center of mass is somewhere over here. Block B's position is like this, and block A's position is like this, which makes sense because block B is at rest and this is where they collide. On the same graph, draw and label 3 lines to represent the positions of A, B and the center of mass of the two block systems as a function of time between 1 to 2 seconds. Now we need to graph between 1 and 2 seconds, and each line should be distinctly labeled. Okay. Now remember, the block B is also moving, which is, I think, kind of straightforward for us to determine because we know that the velocity of block B is now 3 meter per second. And uh, by the way, it was held at it was held at 2 meter already, right? I think I would prefer to take this complete scenario over on that page so that I know what's going on. What I'm trying to say is this block B is now at 2 meters and the block A was at 0 meters. And when block A comes to block B, they kind of collide at 2 meters, which is what is happening after 1 second. Now, block B is moving at 3 meter per second, which is obviously constant. And it moves for how many seconds? 1 second. So in 1 second, what is the distance traveled by the block B? Speed times time, which is just 3 meters. Now, this means that the block B will cover 3 meters. It is already at 2 meters. So 2 plus 3 is 5. It means that 5 meters after 2 seconds. So this is for block B. Now I need to figure out the same thing for block A, but I need the final velocity of A. Initial velocity of A is not given, but we can find from here. We know that the velocity will be distance over speed. Distance is velocity is distance over time. Distance is 2, time is 1, so that will be 2 meter per second. So if we conserve the momentum, we'll say that 6 times 2 plus 0 is equal to 6 times unknown VA dash plus 2 times 3. So 12 is equal to 6 VA dash plus 6. So 6 is equal to 6 VA dash. So the value of VA dash is equal to 1 meter per second. So in 1 second, the block A is going to cover 1 times 1, which is just 1 meter. So 2 plus 1 is what? 3 meters. So let's draw that from perhaps blue. 1 meter is 3, so that will come somewhere over here. But remember, the center of mass will not change because the center of mass is what is the formula for the center of mass? The center of mass VCOM, let me write this over here, VCOM is M1 V1 plus M2 V2 over m1 plus m2. Now, what is m1 v1 plus m2 v2? Isn't that just the momentum? And isn't the momentum conserved? Doesn't matter whether you write P initial here and after the collision whether you write P final. P initial and P final is same. So the velocity of the center of mass is not going to change. So you're just going to extrapolate that dotted line, perhaps with a new color. That's all we can do the best with it. So this is going as a dotted line, and I think I'm going to do the same thing. Oops, that's pretty thick. So I'm going to just, yeah, it looks more like, or maybe I'll just draw from here and then erase that portion. Yeah, that looks more like it. And then I'm just going to do away with this portion. All right, so this is, what is this? This is the center of mass, COM, and the red one, sorry, the blue one is for the block A. I think that makes more sense. And finally, what do we have here? Consider if in the original scenario, instead of colliding elastically, the block collided and stuck together. Describe how the line drawn for the center of mass in B would change, if at all. Briefly justify your answer. Line for the center of mass, it's not going to change, right? Because of the kind of justification which we provided. Whether they collide elastically or inelastically, the momentum is still conserved, right? The momentum is still conserved. So the line will not change. The line of COM will not change because V center of mass is just the momentum over the total mass, and since the momentum is not changing and the total mass still remains the same, so the center of mass velocity will also not change. I hope this makes sense. Any doubts, please post it in the comment section, and I will see you in the next video. Bye bye.